Okay, now I'm going to teach you guys this worksheet or go over this worksheet with you guys. It's called chemical formulas. So here we are given a molecule of glucose has a following chemical formula. Now we need to know how many atoms of carbon there is in one molecule of glucose. How many atoms of carbon are there in a dozen glucose, and how many dozen carbon are there in given 1 dozen glucose molecules. So let's take it by step. So this is one molecule of glucose. So in this one molecule, how many carbons do we have? We have 6 carbons. And then how many hydrogen do we have? We have 12. And then how many oxygen do we have? 6. So in question number 1, it asks you how many carbons there are in one molecule of glucose. So the way we're going to do this is we have one. This is going to be a train method. We're going to use a train track method for all of these questions. So here we're going to do is we start with one molecule of glucose. And then since we want to cancel that one molecule of glucose out, I'm going to put this on the bottom. And our desired unit is carbon. So here I showed you above that these are the amount of atoms that are in one molecule of glucose. And we found out there's 6 carbons in one molecule of glucose. So I'm going to put 6 carbon. I'm going to cancel this out. 1 times 6 equals 6 carbons. Alrighty. Now let's move on to the second question. It says how many atoms of carbon are there in 1 dozen glucose molecule? So another train track method. So we're started off with 1 dozen, which is 12 glucose molecule. And we know from our conversion above here that in one molecule of glucose, there are 6 carbons. So we're going to cross these out. 12 times 6 is 72 carbons. Now our last question says, how many dozen carbon atoms are there in 1 dozen glucose molecule? So we're gonna see, this is our starting material. So we're going to do the same thing as we did in question number 12. 12 glucose molecule divided by 1 molecule of glucose, is 6 carbons. And since we want dozen of carbon, we know that 1 dozen of carbon, I'm going to say C as for carbon, is equal to 12C. So I'm going to put 12C at the bottom, or carbons, over 1 dozen of carbon. So if we times everything out, we get 12 times 6, cross this out, our unit is dozen, over 12 equal dozen of carbon. So here I don't need to do my calculator. 12 over 12 is always 1, so our answer is 6 dozen here. Now my challenge for you, this worksheet doesn't have it. My challenge is solve the 3 problems, but instead of carbon, solve for hydrogen and oxygen. Okay, I hope you guys solved it, and I'm just gonna go over with you. So if number 1 is asking you to solve it, how many hydrogen are there in 1 glucose? We know that glucose is C6H12O6. That's 1 molecule, right? And there is 12 atoms or 12 hydrogen. So if we do the unit conversion, 1 glucose molecule, and then I'm going to put 1 glucose molecule on the bottom, and then 12 hydrogen on top. To cancel out the unit, 1 times 12 equals 12 hydrogen atoms. Okay. And then for number 2, if we solve it for hydrogen, it's saying how many atoms of hydrogen is there in 1 dozen of glucose. So 1 dozen is equal to 12 glucose molecules. So if we do that, we have 12 glucose molecule. Do the train, 1 glucose molecule. And we know in 1 glucose molecule there are 12 hydrogen, so we're going to put 12 hydrogen on the top. If we do that, this unit cancel out, leaving us with 12 times 12 hydrogen atom. So that will equal 144 hydrogen atoms. Sorry. Okay, number 3, it says how many dozen hydrogen atoms are there in 1 dozen of glucose molecule. So I'm going to do the same thing, but convert it into a dozen. So we're going to put 12 glucose molecule, right? We need to get it into hydrogen, so we're going to do the same step as above. And then, since we want it in dozen, we know that there's 12 hydrogen in 1 dozen of hydrogen. So that will equal 1 dozen times it by, divided by 12 hydrogen, equal blank. So here, unit cancel out here to here, leaving us with dozen hydrogen. So if I times it all out, 12 times 12 over 12 is equal to, cancel these 2 out, 12 dozen hydrogen. Alrighty. Now let's solve it for oxygen. So if we add, replace question 1 through 3 with oxygen, it says how many atoms of oxygen are there in 1 molecule of glucose. So our glucose molecule is C6H12O6, and question 1 is asking how many oxygen atoms are there in 1 glucose. We found out there's 6 here. So if our starting material is 1 glucose molecule, we're going to do the train track, and we know in that 1 glucose molecule, there is 6 oxygen, which equals 6 oxygen atoms. Okay, number 2, it says how many atoms of oxygen are there in 1 dozen glucose molecule. So if I do the same thing, I know a dozen of glucose is 12 glucose molecule. So I'm going to do the same unit conversion here. 1 glucose molecule. There are 6 oxygen atoms. So if I do cross these out, I get 12 times 6, which equals 72 oxygen atom. Okay, number 3, it says how many dozen oxygen atoms are there in 1 dozen glucose molecule. So if I solve this real quick, 1 dozen glucose molecule. 1 glucose, same thing as above, because we want to keep it in oxygen. So 6 oxygen. And then we know there's 12 oxygen in 1 dozen. Sorry. So I'm going to put oxygen on the bottom, 1 dozen of oxygen on the top. Cross it out, the unit to double check, leaving us with dozen of oxygen. Times it all out. I know that 12 and 12 will cancel out, leaving us with 6 dozen of oxygen. And that's how you'll solve that one. Moving on to the next questions. It is the same concept, but a little bit different. So it says the following equation represents the combustion of natural gas. CH4 plus 2O2 is equal to CO2 plus 2H2O. So number 4 is asking us to list the product and reactant for the reaction. We know products is here, or reactant is here, because we react the molecules, and then the final result is a product. So your answer here, reactant, is CH4 and O2, product, CO2 and H2O. And then number 5 is asking how many molecules of methane. Methane, it doesn't say it right here, but it's CH4 react. So if we just look at the formula, we're just going to look at the coefficient to find how many molecules are there in the reaction. And this is already balanced, so we don't have to balance it. So knowing that, we found out that there's only 1 molecule of CH4 being reacted. Now we need to find how many total atoms of oxygen is reacted. So this is a little bit tricky. You will do the same thing here. Look at the coefficient of the oxygen, right? It's 2 CO2, right? But it's asking for individual atoms. So do you see how there's 2 oxygen in 1 molecule, if that makes sense? So what you will do, you just do 2 times 2, which equals 4. That means there will be 4 atoms of oxygen. Okay, if this doesn't make sense, let me draw these out for you. So oxygen, a molecule of oxygen is O2 because it's a diatomic, hope is right, spelling it right, molecule. Okay, they always come in pair. So a pair of oxygen is usually blue, I think. You just pair it up. Those are oxygen. So there's 2 oxygen here. Now in the reaction, they're saying that there's 2 of those. So that means we have 1, 2. And these are my oxygen atoms, saying that, or oxygen molecules. So we have 2 oxygen molecules, but in each molecule there's 2 atoms of oxygen. So that's why you do 2 times 2, or just add it up, 1, 2, 3, 4. So leaving us with a total of 4 atoms of oxygen. Okay? Hope that makes sense.